taking this question from the Eastern Cape, June 2023. The diagram below shows the graph of f at x and g at x. The two graphs intersect at S, the y-intercept of both graphs. R is the x-intercept of f, the asymptote of f, cut at T, the turning point of G. 4.1. Write down the coordinates of S. So S is the y-intercept of G. The coordinates there should be 0 is to 3. 4.2.1. Determine the coordinates of T. I am told that T is the turning point of G. In order to find the x-coordinate of the turning point, we use the equation for the axis of symmetry. Our B is a 10, 2, and our A is a 5. That's a -1. And then we're just going to substitute the value of x of the turning point into the mother function. That's a -2. This means that the coordinates of T, that's a -1, is to -2, 4.2.2. They want the values of P and Q. P and Q represent the asymptotes of F. Y there, okay. So Y there should be equals to -2 and X should be equals to -1 because the coordinate of T and -1 is to -2. So P is equals to -1 and Q is equals to -2.2.3. The length of OR. I am told that R is the x-intercept of F. Then for x-intercept, we set y equals to 0. 0 is equals to 5 over x minus 1, which is going to be a positive. And then that's going to be -2. This is 2 into x plus 1 equals to 5. 2x plus 2 is equals to a 5. 2x is equals to a 3. So x is equals to 3 over 2. The coordinates of R should be 3 over 2 is to 0. OR is 3 over 2 units. 4.2.4. They want the range of G. The range represents all the possible y values of G. Well, the turning point of our graph is at y is equals to -2. So the graph can start from here and go all the way upwards. So the range should be greater or equals to -2. Then 4.3. Determine the equation of the tangent to G at S. G of x is equals to 5x squared plus 10x plus 3. We know that the equation of a straight line is given by mx plus c. So we need to find the gradient when x is equals to 0 because the coordinates of s is 0 is to 3. In order to find the gradient, we need to find the derivative. So this is 10x plus 10. And then we want to know what the gradient is when x is equals to 0. So I'm getting a 10. That means that the gradient is 10x plus c. So this means that the graph will cut there. So this is 0:3. So this equation should be 10x plus 3. The axis of symmetry of f with a positive gradient. Okay. The axis of symmetry, it refers to that line that cuts. Let's just try and make it cut. So we are looking for that line. Y is equals to x plus c, because we want the gradient to be positive. 4.3.2. We are going to say y is equals to x plus c. And then for these two, we substitute your asymptotes. Y should be equals to -2, and then your x should be -1 plus c. So c is -1. So the equation is given by x minus 1. 4.4. For which values of x will j prime of x multiplied by f of x be less or equals to 0? So f prime represents the gradient of g. So I have two functions. I have one where I have the gradient and then f of x. In order for me to multiply two things and get something that is less or equals to 0, it means that the product of the two must be negative. So when I multiply a negative with a positive, I must get a negative. Or when I multiply a positive with a negative, I must get a negative. So I'm going to start with the first scenario. I am looking for where the gradient of g is negative. The gradient of g is negative this side, all the way to there, where it is equals to 0. And then f is positive. Well, f is positive from here going upwards. Okay, so this doesn't really satisfy. Okay, so the first scenario doesn't really. Okay, let's check the second one. The gradient should be positive, and then my f at x should be negative. Yeah, so the gradient is positive and my f is below the x-axis. So this means that x should be greater or equals to 3/2. Okay, let me just double check this. Negative, negative. And then my f at x should be above. But from this point here, going this way, this is below. So no, there's no solution for that one.